Hello. So this is the very first lecture on chapter 5, functions in Python. So let me share my screen and get started, and then we can see how we are going to go forward in this lecture. So when you are logged in into your REPL, it should look something like this. Or if you're in your home, this is how it's going to look like. But when you click on My REPLs, you really don't have a whole lot going on here, and you will have an option to create a REPL. But instead of creating your REPL, I'm allowing you to copy a REPL from my instructor account. So to be able to access my instructor account, change the handle from your username to @SuchiRhoda, which is my handle. So you can see all of the REPLs that I have created so far, and go to view more and look for um, Chapter 5, functions. There you go. So when you click on it, you can see the content of what's in my REPL, and as you can see, the main.py is empty. I haven't written any code yet, but that's what we're going to do in this lecture. So I want you to go ahead and fork. And what fork does is it creates a copy of all of the code, or all of the content from my REPL to your REPL. So you can change the name to functions or put your name in there, whatever, but I'm just going to copy it the way it is, and I'm going to fork it, which will take me back to my student account. So as you can see, the handle is not Suchi anymore. It's my student handle. So it'll take a second to copy over everything. And this is the tutorial I have designed for this chapter. You can go to the table of contents, and then you can look through everything that's in there. So we're going to start off with the very first thing. But just in case you have to stop the lecture and then go back and then come back another day and do it, you can always find this REPL under so if you go here and you go to my REPLs, you can always, whenever you log in, go to my REPLs, and you will always see this was for 34 seconds ago. So you click on that, and then you can continue your work. So here we go. So that's the basic introduction of how to fork a REPL and how to use it. So functions, so that's the chapter we're going to cover today. So what is functions? Function is a group of statements in Python that perform a very specific task. So basically, when we have a really huge program, we kind of break it down into logical subtasks, and each of that subtask is called a function in Python. In most other programming languages, it's called a function. So before we go on to how to write a function, how to define a function, and all that, let's talk about why do we need functions. So a program is nothing but a real life problem having a programmatic solution. That's what a computer program really is. So in real life, so think about, you have to organize a birthday party. It's a really small task. It really doesn't take a lot to do that. But imagine planning for a wedding. So there's a lot of components. You have to think about the caterers, the flowers, and the food, and the bridesmaids, and the bridegrooms, and all of these things. And this becomes too much for one person to handle. So you would logically break it down into the appropriate, say, committees or divisions, and you can try to accomplish that task. Or another example being the university itself. Take a university. It is so vast in its operations that one person or one entity cannot take on all of that. So what we do is we kind of break it down into departments. So logically, admissions department is the first, or recruitment is the first entity that you as a student would encounter when you interact with the university. They try to recruit you, and then once they get you in, admissions will take care of all your admission forms and all the data that you need to provide. And then from then on, maybe if you want to apply for a scholarship, you go to the scholarships department. Or after that point, you can, if you want to get into a dorm, you go to the housing department, and so on and so forth. So you know how all that goes. So if that is a real life scenario for a university, so if you want to write a program for a university, so logically that's what you would have to be doing, is break that whole program down into smaller subtasks, and they have some logical meaning too, because admissions handles all admissions data, admissions things that has no relation with enrollment or registrar. They might interact a little bit, but their data is different. So that's so you would logically design a function for each of those. So that's why we use functions in a program. So a modularized program by definition is any program in Python that is using functions. So for example, let's take a scenario where so far you've written your code without functions, and that's how it would look like. Let's say there's a bunch of print statements. So I'm going to try and keep it really, really simple. I'm going to say, hey, as a student, the first thing you do is you fill out an admission form, and that is step one. And step two, step three, I'm not elaborating what those steps are, but I'm just saying these are all the steps you have to do. Then you get to do the next steps. So we know how the sequence of execution goes in Python. The first statement that it encounters gets executed, and then the second step, so on and so forth until there are no more statements to execute. So if I run this, logically, these are all the steps the student would take until the point of enrollment. So this is when you're not using functions. But as you can see, all of these steps are pertaining to admissions. And all of these steps are pertaining to scholarship, and all of these are for enrollment. So logically, what as a programmer, what I can decide is, hey, I can write a function for all of these steps and call it, say, admissions, and I can write a function for all of these and call it, say, scholarship, and I can write another function, and then that becomes easier for me to handle. So when you are using functions, your code suddenly is going to start looking something like this. So I'm going to delete all of these previous statements, or I'm just going to comment them for now. So gray is commenting. So when you put a hash symbol in front of any line of statement, it becomes a comment, and Python will ignore it when it is executing. So basically what I've done here is I've broken down my code into functions. So whenever you see a DEF key, that means that that's a definition of a function. We will see that in detail later on. So I have grouped my code into three different functions, and I've given a name to each of those functions. And my entire code now is only three lines of code, which is calling this function admissions and scholarship and enrollment. So when I run this code, the same output is established. So basically, um, when you use functions, that's called a modularized program. So this, by definition, is a modularized program in Python. And let's see what else. So whenever you're using functions, what are the benefits? The code becomes simpler. So let's see. So all of these functions that I've written are in main.py right now, but technically they could be in their own file. So this function can be in its own file called admissions.py. This can be in its own file called scholarships.py. And basically your code is three lines now. What it was, 9 lines of code earlier is only 3 lines of code because you've broken them down and you've so much, think of it like you've created a cross reference. So, and also you can reuse the code. Say, for example, a student leaves the university and then he comes back again and he has to go through the process of admissions. You don't have to write the whole code again. All you can do is you can call on the admissions function one more time, and voila, it's going to add those admission steps, all the four of them again at the very end. So 1 line of code, and you're able to accomplish all 4 lines of code that were established. So basically, your code is simpler and you can reuse your code. And also, if there's any errors or any problems, you can isolate to that particular function and say, hey, this error is coming from this function. And then you can eliminate that, or you can simply debug. So let's say, for example, in this program, I forgot to put a single quote, and my program obviously is going to break. So I can simply say, hey, I know that the problem is coming from admissions. So, well, that's not the greatest example for now. So let me backtrack. And I will show how we can do the testings better. Um, and Faster development. So earlier, when you were doing your coding, your program, it was just you writing an entire program, whatever 12 lines of program, because only you have access to this file. But like I said earlier, admissions function can be written in its own file. So another person, another programmer can be editing that file and building that program, while another person can be having access to scholarship.py, and they can be writing code for this and another person. So basically, when you have now teams of people being able to write code simultaneously, which not only facilitates teamwork, it also causes faster development time. So these are pretty much the basic advantages of functions. And for me, the best the best usage of functions is when you reuse the code. So, and we will get the reuse part is pretty cool because, say for example, admissions decided, hey, we want to add a step 5. So earlier when we did not use modularized program, so basically our code would have looked something like this. So a student leaves and he comes back and he has to go through all of these steps for admissions again. Not only that, now admissions has decided to add one more step. So now you are having to do that in 2 different places, right? So anywhere admission steps appear, you would have to put, okay, the admissions added another step. That's step 5. But using functions, so let's go back to how we were doing things with functions. All we have to do is we have to put that line of code in one place. And when we execute the code, see the step 5 is added here as well as here because we're pretty much calling onto a reference of an existing function. So basically the reuse facilitated us to take advantage of any newer changes, not having to make it in multiple places in my program. All right, so let's go on to the next task, which is main function. So anytime you're using modularized program, it is very important to have a main function. Why is it important? So think of it as an analogy. Whenever if you have seen an orchestra, string quartet or something, when there's different people playing different instruments, there's a conductor who decides who plays when and for how long. So the main here is something very similar to that. Python is a very high level language and it doesn't force you to have a main. Like we've seen earlier in our earlier example, we didn't have a main function here. So nowhere can you see main here, but there are other programming languages like Java that will, it's a mandatory thing for you to have main in there. So Python is beautiful in the way that it doesn't force you, but um, the rule of thumb and a good practice for a good programmer is to have a main function. So if you decide to use functions in your program, then the first thing you have to do is you have to have a main function. So main is where the mainline logic for the programming resides. So let's see how we can define a main function, and I will explain that to you. So this def main, we have seen that earlier too. So whenever you see def, that's a keyword in Python. You cannot use that for a variable name. It's a reserved word. So def space main, all in lowercase, and open close parentheses and a colon. That is called the main definition, or it's called a main header. So for any, if you want to define any function, this is the standard way to do it. Main, however, you have to use main all in lowercase. You cannot combine the case. So this is a built-in function in Python. So this is how your main would look, main header would look like. Once your header is done, then you would put enter. So I'm just going to leave that comment in there. So you would have an enter, and then whatever statements you want to put in your program can go inside main, but they have to be one indent over. So an indent can be a tab space, a tab character, or one space or 2 spaces. In this case, REPL is beautiful in the way that it automatically puts the indent for you if you write your program correctly. So let's say this is the main header. If you write it correctly and you hit enter, these 2 spaces are automatically put in by REPL for you, and then this line will signify all the lines of statements that fall within main. So for example, for whatever reason you mess up your syntax, of course REPL will flag it that there's something missing. If you still ignore that and hit enter, then it's not going to put that indent for you. So things to notice when you're using REPL is friendly. It will help you in a lot of different ways. So make note of all of that. So anyway, so once you've defined your main, every statement inside main will go in an indented. So if I run this program, will it print hello world? It did not. I wonder why. Well, defining a function, which is what we did here, is not enough. We have to call the function. So what is calling the function mean? So the main function call, you call a function by its name, and in this case, it happens to be main and open close parentheses. That's it. So this def key with the name and a colon is the definition, and without the def key and without the colon, it is a function call. So rule of thumb, I want you to remember, main function call will always be at indent 0. That means it will never be like that. It will never have a single, it will have a 0 indent position. So now that I've called the function, it will call on def, def main, and it's going to see, okay, what are the statements inside that, and it will execute every single one of that. So this is the most basic modularized program in Python, just with one print statement. So if you still need more explanation, you can go to closer look and see how that goes. So as a rule of thumb, main function will always be at 0 indent. When I say 0 indent, that means there will not be any leading spaces. So I've given a couple of try these options for you, or I think only one. So try to add another print statement in the main and see what happens. And I've given the answer if you don't know how to do it. So one thing to always remember is a function must be defined before the function call. So in this case, what happens? So I'm going to just do definition here because the def key, and I'm going to call, this is a function call, and the function name happens to be main. So what happens if I call this before the definition? Then Python is going to say, hey, I have no idea what you're doing here, because the definition occurs after the call. So rule of thumb, always define your functions first before you call them. So for functions to work, you need two components. One is the definition, another is the call. So all right, so we have done Python's inbuilt function, that's main first. Now let's write our very first void functions. What is a void function? A function that doesn't return any value to the call after the execution is called a void function. So for example, for now, let's just say this is a void function because all it is doing is it is printing something. It's not returning any values. So we will see what returning means and how to return values later on. But whenever there's no return statement in a function, it's called a void function. So let's write our own custom function. So how did we define a function? First, we need the def keyword, and then we're going to write our function name. So function names have the same naming convention as that of variables. You cannot have spaces, and it cannot start with a number, and it cannot have special characters other than an underscore, and it cannot be a reserved word in Python. So these are all the naming conventions we have seen how to use for a variable. So all of those are applicable here, and also uppercase and lowercase characters are distinct. So if you write a function with uppercase A apple and call it using all lowercase apple, Python is not going to recognize that. So remember that Python is case sensitive in that case. So, all right, so let's write our function header. So function header consists of, the first component is the def key. The second is the function name. So I'm going to call it first function. Okay, and then come the open, close parentheses, open and close parentheses. That's the third thing. And the last thing is the colon. That's it. My function definition is done. So I'm going to put a hash symbol, and I'm commenting it, and I'm saying this is the definition. So whatever I want my first function to do will be inside this. So I'm just going to copy this, and I'm going to say, all right, so I've defined my function. Now I'm going to write the body. So all of the statements that are indented inside this, so whenever I say inside the function, that means with an indented space. So can the statement have one of the statements have two spaces and the other one have one space for indent? No. Whatever indent that you pick, two spaces or one space or a tab character, it should be uniform for this entire function. So if you write another function and you decide I want to use a tab character for my indent, and then you end up using tab spaces for all that function, that's okay for Python. But as far as this function goes, if you start off with two spaces, then you're going to keep using the same convention. So Replit does all that indenting for you. So good news, not to worry about it. So let's see, I've written my first function definition, and then I have put all the function body in there. So let's execute and see. Oh no, all it's doing is printing hello world. Why is it not printing this? Well, we have defined the function, sure, but we have not called it. So all the function calls will be inside main. So now here, we can decide, do you want to place the function call before hello world or after hello world? That's up to you, but wherever you do it, use the name of that function, open close parentheses, and there you go, you've called that function. So first hello world is going to execute, and then first function is going to get called. So what's happening there is, there we go, it's printed hello world from the print statement, then first function is called. So the execution jumps to the very first statement in this function, and it says it's printing, this is my first function, and then it's printing the next, its execution goes to the next line of code, and it prints hip hip hooray. After this, there are no more statements to execute. So the function, the control jumps back to main, and then after first function, there is no more statements to execute. So the program ends. So how about I put an end here? Okay. So now if I do that, I'm just going to erase the previous output, and I'm going to say, so it says hello world. So the logic goes here, it starts here, and then calls the first function and executes these two statements. And then after the execution, it comes to, what is there another statement after first function? Yes, there is. There's a print statement that prints end. So it prints that, and then the program execution ends. That's it. So the very first line of code that gets executed in a modularized program is the main function call. So Python looks for, is there a main function call? And yes, if there's a main function call, it jumps to the main function definition, and whatever body is in there, it gets executed. So that's all there. So any rules of thumb, always define a function at a zero indent position. So as you can see, all the defs are at zero. The body is the first indent level. If I use an if statement or a for loop, and they will have their own indent. If 5 greater than 7, then they will have their own indent based on that block, and Replit is going to place that for you. But if you're simply having print statements, they will all be in indent 1 position. So that's the rule of whenever you're defining your functions, I do not want to see any indents there. I don't want to see that, because that's not going to be correct. So 0 indent positions, no leading spaces, until we get to chapter 10 or chapter 12. So I have given you a couple of try this, and you can create your own function called second function, and then have two print statements and use the same rules of defining and putting the function body in it, and make sure you call it wherever you call it. It doesn't matter. That's up to you. So the answer is provided for you if you need it. So let's go on to the next section. Hello. So this is the second lecture for chapter 5 functions, and let me share my screen and get started, and let's pick up where we left off last time. So we finished off writing our very first void function, and I'm hoping you've done your second function as well. So let's see how the execution of sequence is when you're using functions in Python. So in a modularized program, if you weren't using a modularized program, Python program technically begins at the very first statement and executes each statement sequentially until there are no more statements to execute. But when you're using functions, so there's a remember here, a good practice is to write a program in main.py. Python doesn't force you to have to write in main.py, but a good standard of practicing, program practicing, is to write your main function in main.py. So the main function is defined in main.py, and the main function is called. So first, we've already seen how to define the main function. We've seen how to call it. All the programming language, all the programming logic should go inside the main definition body. And when the call is encountered, and then we call the main function, and when function call is encountered, the execution now stops. So what was executing sequentially earlier, now as soon as it sees a function call, it'll jump to the definition of that function and executes whatever statements are there in that function sequentially until a return statement is encountered or there are no more statements to execute, and then it jumps back to the main program right after the function call and sees are there any more statements for me to execute. So to give it an easier analogy for you to understand, I have created a visual. So for example, if you were baking a cake and you were following a recipe book. So let's say you want to bake a chocolate cake with buttercream icing. I hope that's big enough for you to see. All right. So these are the steps. It says prepare the batter, and then it says refer to batters in chocolate. So then you got to jump to, okay, where's the batters page? And then in that you find where's the chocolate one. And then you follow these steps sequentially. And then once you're done, you go to step number 2, bake the batter. And then the next step would be prepare icing, and then there's refer to icings and it says buttercream. So now you got to look for the page where it says icings, and there it is. And then you're going to look for where's buttercream. Okay, there it is. And then you follow all of these steps here. Hey, but there's another refer to flavors vanilla in this. So you jump to that, you finish all of these steps, and then you come back here. There's no more steps here after all the, and then you jump back to the 4th step. So this is very, very, very similar to how a Python program looks. But I do have one disclaimer though. Please do not follow this recipe. It's not going to be very good. I just threw something. I'm not a very good baker. I just threw in some steps that made sense to me. So, but anyway, so that is exactly how Python programs execute. So let's see if we wanted to write that chocolate cake with buttercream icing we just saw without functions, how would that look like? So we would have all of these individual steps, right? So we have to prepare the batter, and then we will jump to that page, grab all the print statements, all the steps for that, put it in a print statement, and then we go on, so on and so forth. So all of these steps will create this cake for us, the chocolate cake with buttercream icing. But what if I wanted to use functions to transform this program into a modularized program? So technically what I would do is, hey, this is the steps to create a chocolate batter. So how about I put that in its own definition, and I'll say def chocolate batter. Let's say that for now. And then I'm going to put all those print statements in here. Of course, that's not going to work unless there's a function call. So before I do all of that, wouldn't I need a main function? So all of these will go inside main. So all of these steps will be inside. So how do I say they're inside main? All I'm doing is put a tab character. So now basically all of these statements belong to main. And instead of this, all print statements, I'm just going to put a function call in here. That's it, as simple as that. Now, if I execute this, obviously it's not going to print anything because I haven't called the main. Okay, so this is pretty much the basic layout. So all the statements inside main will be at indent 1 position, which is 2 spaces. So make sure you have all those 2 spaces. If it's not, then Python is going to let you know. So anyway, the execution starts at the main call. So the execution now jumps here. It'll execute this, and then it sees a function call. Oh man, so it's going to jump to the function call, and then it's going to execute each of these sequentially, and then it's going to come after the function call and start doing printing all of these. So if I run it, obviously it'll give me all the steps that I need to take to do a chocolate cake with buttercream icing. So now I know that buttercream icing also is, I can write it, let's say buttercream icing in its own function. For now, I'm just going to make it easy on myself to copy and paste. So now I'm going to define a function called buttercream icing, put a colon in here, and move these 2 print statements inside this. So basically I have one function called chocolate batter, another function, buttercream icing. The third function is the main function. So again, when I execute this, these steps are gonna get away. They're not gonna be there anymore. Take the so these two steps will not work because I have defined the function, but I have not. There you go. I have called buttercream icing, and then it jumps and it prints these two. Fine. Also, for vanilla flavor, I can create another function called vanilla flavor. And what I'm gonna do is make it easy on myself for copy pasting. So right now, when you see that red underline, Replit is telling you, hey, Python doesn't know what this means. Okay, I'm like, all right, I'm going to define it. But guess what? We have to define the function before we call it. So I'm going to define it before the main. And there you go. I've put all my print statements. So, and that's it. That's all the steps in your program. And what was a really long program earlier is now just a few lines. And so the execution will jump from one place to another. And oh, the buttercream icing has the vanilla. Okay. Okay, so this one is not in here. That will be inside the buttercream icing. Right. So that's where it will be, not in the main, because no, that's how our recipe was. Remember how the recipe was looking? That the icing had the reference to this. So basically the function call also will be inside buttercream. So I know that it can get overwhelming. Just take a minute and understand the recipe, how the recipe is flowing, and then understand how your program is flowing, how you would be writing the program to see the steps in the same order as how your recipe would be. So there you go, using functions. So I'm going to put notations here, and I'm going to say this is a function call. This also is a function call. Type correctly. And here inside this is a function call. And each of these is a definition. So so wherever you see a def key, that is a function definition. And main also is a function call. So as you can see, the very first line of execution starts with the main function call, and then the execution goes so on and so forth. As soon as you see a function call or Python sees a function call, it will jump the execution. It will stop executing further. It'll jump here, and then it'll go through all of the steps, and then there's no more steps in here. Or you could also place what's called a special reserved keyword in Python called return, which will tell, hey, there's nothing else to do here, go back. So when it goes back to its calling function, the next statement in the calling function. So who is the calling function for chocolate batter? That would be main. And then it goes back to its calling function, does the next steps, and then as soon as it sees this function call, it jumps to this function, and it starts executing in line in sequence, and then it sees another function call. So it jumps to this function, finishes all of these, and then when it is returning, it's not going to return to main, it's going to return to whoever is calling it. And in this case, that happens to be this function. So it goes back to buttercream icing, and then the very next statement after this is nothing. There's no more statements to execute after this function call. So now it goes back to the original calling function for buttercream icing, which happens to be main, so on and so forth. So as you can see how quickly your program got overwhelming and you don't see how it flows. So this is exactly why we use what's called a hierarchy chart. So I have a few things for you to look here. If it doesn't make sense, you can go back and read through the closer look and see if that makes sense. And I've also given this whole program with functions for you. So if I delete this, you will still have it available for you. And then things for you to remember is the function definition must appear before the main function call. So all of these functions should be defined before you call the main function. And you have, if you try this options here, and then I've also given you the answer. If you don't know how to do it, then that's fine. um, Another thing, like I told you earlier, each of these functions can be in their own separate files, and we will see that in just a second how to do that, um, and what they are called. And I think I've already written the module for, yeah, for you. So basically, so what I can do is I can move each of these function into a separate file. And then the only thing that will change is when I'm calling that function, because it's not in the same function, I have to give it the location, or I have to import that. So let's see how modules work. So we're going to cover modules again later on, but for the intent of this class, we will be writing all our functions in a separate file, and that is what we're going to call modules. So you can open the sidebar at the top. So these are the tutorial files. So main.py is the file we've been working on. So if you want to add a new file, and now I'm going to call it batter.py, and this is where I want to place all my batters, not just chocolate batter, but any other future batters that I want to have. I'm going to put them all in this batter. Okay, um, batter.py. And similarly, I can create another file, and I'm going to call it flavor.py. And where is vanilla flavor? So all my flavorings will go in this file. So the definition will be the exact same thing. Definition will always be at zero indent, and all the function body will be at in position 1. And then I will create another file, and I'm going to call it icing.py. And then I'm going to move the buttercream icing here. Okay, so as soon as I do that, let's go back and delete everything, and I'm gonna move the sidebar over here. So now I gotta fix my program, because Python doesn't know where all of these are. So as soon as you see these red lines over here, move this here, and move the icing here. Actually, flip icing main. So as you can see, REPL will let you navigate through all these panes. You can add as many panes as you want and have as many files open as you want. So in this, I want to also open batter.py. So I have all my files opened, and you can toggle back and forth between all your files. So there we go. Right now, Python is saying that, hey, you are making a call to this function called chocolate batter, but I don't know where it is. So that's where we use an import statement. Import is a reserved keyword, and after the import, you want to give the name of the file that you can find this function. So where is chocolate batter defined in? It's defined in this file, and the file name is batter. So all we do is batter. We don't do .py. And then when you do that, you prefix the batter, the file name, in front of that. Now all of a sudden the red line is gone. So we do the same thing. So if you want icing, you want to import the file named icing, because that's where we've defined this buttercream icing. And then we can say icing dot buttercream icing. There you go. All the red lines have gone, but there's one more place where there's another red line, because vanilla flavor is inside flavor.py. So I'm just going to do flavor, and I'm going to prefix this with the name of that module. So each of these, even though it's a .py file, according to Python, we're going to start calling them modules. So they are defined in their own modules. So basically, just by changing the sequence or the order or whatever function you're calling, you can change your entire recipe here. So the icing chef can take care of all the program, all of the icings that he wants to do here. So if you want to add another vanilla icing here, you can create a new function and call it vanilla icing, and or whipped cream icing or whatever. And flavors also, you can do more flavors. So I think our cake recipe has more of the print statements, and I want you to try and see if you can do that. So that's one way of importing files. So when we simply use import batter, we're having to do a prefix. There's another way. People like me, I don't want to type a lot of stuff. So what I do is I can do import from batter, import chocolate batter. And Replit will help me. It'll tell me what are all available for me to use. And in that case, I don't need to use a prefix. So there's two differences. I'm going to leave them both here for you to take a look. So if I do it this way, just by using import icing, whatever functions are in icing, right now there's only one, but you could have 100 different types of icings. All of them will be imported, but out of that, you're only going to use buttercream icing. So in this way of importing, you have to use a prefix. If you're importing like this, all it will import is the one function that you're using in this. In that case, you don't even have to use any prefix, but the format is different. You use from, name of the file, import, name of the function. That's as simple as that. So I have given you, if you can also check inside modules here, and that's a separate REPL. You can import that or fork that and see how that looks. So there you go. I've written all my batters: chocolate batter, vanilla batter, and then in icing, I have buttercream icing, I have cream cheese icing, so on and so forth. And based on all of these functions, how your recipe changes is also different. So anyway, so that is how you can write modules inside of Python. So as you can see how your code has become so complex so easily, that's why we use what's called a hierarchy chart to give us a visual representation. So if you take our original recipe of chocolate cake with buttercream icing, in a visual format, I can write it something like this, that the main function is calling chocolate batter. It is also calling buttercream icing, but buttercream icing is also calling another function called vanilla flavor. And that's exactly what was happening there. And I can also tell it where to look for those functions. So basically earlier I had all my functions written inside of main.py, but in this way, then I would have to say, instead of main.py, I would be saying batter.py, here it would be icing.py, here it would be flavor.py, but the flow of how the program is happening will be the same because main is calling only two functions. So this is called a hierarchy chart. It will tell you who's calling who. And when you say who's the calling function for vanilla flavor, you got to look up one level higher and see, oh, buttercream icing is the one that's calling vanilla flavor. So once vanilla flavor, all the statements are executed in that function, it will jump to the next statement inside of buttercream icing. When all these statements are done, then the execution jumps to the next statement in main. So hierarchy chart lets us take a look at how a visual representation very easily what's happening in the program. So I want you to try this. Draw a hierarchy chart for vanilla cake with cream cheese icing. So if you want the recipe will be inside execution. There you go, inside the recipe book. Try this recipe. Okay, so we just wrote this recipe. How about you try to write this recipe and also the hierarchy chart for that? Have your batters in batter.py if you want, or everything in main.py. Try it and see how that goes. So let's see what else we have. So I'm going to take a stop right here, and we're going to look into variables, local variables and scope in the next lecture. Hello. So this is lecture number 3 in chapter 5, functions. Today we're going to see where we left off last time was we learned about a hierarchy chart. Today we're going to see the opposite. So given a hierarchy chart, how can you write your code? So we've done the opposite the other time. We had the code and then we wrote a hierarchy chart. So for example, if you're given a hierarchy chart like this, how would you write a hierarchy chart for that? Code for that, sorry. So let's get started. So as you can see, main is defined in main.py, and that's a default. There's nothing new there. And then hierarchy chart only has function calls, who's calling who and from where, maybe. But other than that, there's no information. So I don't know what to write in my main. What is my function body going to be? So when I know the structure, but I don't know the specifics, that's when I use what's called a keyword PASS. PASS lets me, it's like a placeholder for a statement. It really does nothing. It just moves the execution one line down and next line is nothing. So if I don't use pass, Python is going to think, okay, you are going to give me a function body. And if I don't, it's going to, Replit is going to flag it as a red line, and you hover on it and it can tell you that that it's expecting something. So that something can be a pass. So, and the main function call will always be in main, and I've defined my main so I can call it. And inside the main function, so now I get down to, okay, main is calling step 1, which is defined in main.py. According to this, the definition is also in main.py. So I'll go ahead and I'll define a function called step 1, and then I don't know the specifics, so I can go ahead and do pass. But at this point, I know that main is calling step 1. So that means the function call, the definition is done, but the function call for step 1 is supposed to be inside main. So I can choose to keep the pass and do step 1, which is the function call for the function I just defined, or I can remove pass and have step 1 as my first statement. So dealer's choice. I like to have my pass just in case I decide to comment any of my code. Pass will make sure that my code is not broken. So same story here. So step 2 is defined in main.py, okay? And main is calling that. So inside main, I'm supposed to call a function called step 2, but it's not defined right now. So I'm going to define, step 2, and then pass. And then the function call is going to be inside main. Oh, see how Replit is very helpful, where it's going to tell you if you write a function name that you haven't defined, it's going to give you a red line. So same story, step 3. So this is the easiest possible way where everything is defined in main. So what if instead of main.py, this was functions.py? Then you would be creating another function called functions.py, define step 2 inside functions.py, but the call will still be inside main because it is child of main. So hold on, I think this is step 4. Which I haven't defined yet. So I'm going to go ahead and change that. So then comes the last one, which is also defined in main.py. And that is step 3 and pass. But according to my hierarchy chart, step 2 is the calling function for step 3. So I'm going to go look inside step 2 and then place the call for step 3 there. There you go, without any knowledge of what the code is going to be based off of a hierarchy chart and using the pass placeholder, I can write a skeletal structure of my program. And pass can be used not just inside functions. If you have a program logic that say if light is equal to red, then I want to do something, which I don't know what that something is. So, and then I'm going to say else, I'm going to do something else. I don't know what that is yet. So I'll use pass. So as a programmer, you can get your basic broad strokes out of the way, and then you can decide what the intrinsic details of the code logic is going to be. So pass can be used in if, for, anywhere you have a block, you can use the pass keyword. So for now, that's where I'll leave you with. And then we're going to proceed to local variables and scope. All right, let's see what local variables and what's the scope of a local variable in a program. So when we assign a value to a variable inside a function, we create a local variable inside that function. And the local variable created inside a function cannot be accessed by statements that are outside the function. So what does that mean? So let me just copy this code snippet. And just by a look of it, I have a function called getName. And of course, I have main, and main is calling getName. So let's start the execution as Python would do it. So the very first line of code that is going to be executed is the main function call. So when this encounters, then the execution jumps to the body of the main. And the very first line in that is another function call. So the execution now jumps to the very first line in this code, in this function, and it happens to be an input statement that gets the name from the user and stores it in a variable called name. All right, so after this, there's no more statements. So the execution jumps back to the next statement after the function call and it tries to print hello name. So ideally, what you would think is yes, it would Python would print hello and whatever the user enters as name. But as you can see, Replit is already flagging it as underline and it says undefined name. That is because as far as Python is concerned, name only belongs to wherever it is defined. So at this point, it is defined inside getName. So outside of getName, no other function, no other code can access that variable. So that's why even though main is the one that called getName, main still cannot see what name is unless this function somehow figures out a way to pass this name to main, and we will see that later on. But that's called a local variable. So name in this case is called a local variable, and the scope, or where it can be accessed, is called a scope, is only in the function that is defined it. So in this point, it's get name. So I would like to give you a cheesy example here. Think of main as real life. Okay, so real life, Tom Cruise's name is Tom Cruise, but if he acts in a movie, say let's say Maverick, his name in that movie is something else. It's Maverick. So outside that movie, his name goes back to Tom Cruise again. Nobody, if you ask for Maverick, it's not going to look up Tom Cruise. It's going to be like there's no person called Maverick. So that's a very cheesy example, but if that helps you understand, so this local variable has a scope only inside this function. So if I define another function, another variable in this, I'm going to say just I'm defining a string and I'm calling the variable name is first. And this first is the local variable for main. No one else or no other function will have access to this unless main decides to share it with it through some means, and we will see that later on. And the scope of this first is only going to be inside main. So there's a couple of things to here. Remember, a local variable cannot be accessed by code at a point before the variable has been created. So just because name is a local variable to this function, can I try to print name before I even assign it? There you go. So even though the scope of name is inside this function, I cannot try to access it before it is assigned any value. So that's a thing to remember, and we've seen that in our previous coding. Scope. So variable scope is a part of the program in which the variable may be accessed. In the above example, the scope of the variable name is the function getName. So name scope is only in getName. So one more thing to remember about scope, a variable is visible only to statements inside the variable scope. So anywhere, if you have an if or a for or any other uh, or a while, name is accessible to all of that code, but only that code. So that is local variables and scope. All right, local variables with same name. So just because we've said each function gets to have its own local variables and the scope is limited only to that function, we can have multiple functions which can utilize a same variable name but still not have any conflict. So different functions can have local variables with the same names because functions cannot see each other's local variables. So for example, let's see, we have the main function and then we have two other functions. So let's follow the course of execution. The first thing is the call to the main function, and it jumps to the body of main, which is a function call to Texas. So it jumps to here and it says birds is equal to 5,000, and then we're just printing Texas has this number of birds. And then the execution jumps back to the next line, which happens to be a function called California. And now birds is 2,000 and print California has 8,000 birds. So technically you would think, well, there's this function, this variable named birds in this function and birds in this function too. So isn't there a conflict? But no, because once Texas function call is encountered, and Python executes all of these statements, and it jumps back to California. Right before it jumps back to California, this variable doesn't hold it. That variable is completely destroyed. And then once it calls California, birds is equal to 2000 is brand new. It's a brand new variable created with a brand new variable value. So that's why, because the scope is local, we can have the same variable names in different functions, and that will not create a conflict. So there we go. As we can see, accordingly, Texas has 5,000, California has 8,000 birds. So there's a closer look. If it doesn't make sense to you, let's look at the next section. All right, so passing arguments to functions. So just a minute ago, I told you if main decides to share any of its local variables with a function, it can do so. So that is called passing arguments to functions. So for example, let's take this. So I have a function called main, and it has a local variable. So I'm going to notate it local variable of main. And this local variable, I can decide to share with a function called showDouble. So I have defined another function, and earlier our parentheses used to be empty, but now as you can see, I am placing this variable name, which is nothing but I am trying to pass the value of 5 to the function. So now when I use another variable name, it doesn't have to be number, it can be the same as this, but I am storing this value. I'm accessing this value from main, and I'm passing it, and while I'm passing it, I'm also renaming it to number. So according as far as showDouble goes, now this is number. It's not value anymore as it was in main. So main calls it value, showDouble calls it number. So showDouble does some sort of a computation, and it just simply doubles that value, and then it stores in another variable called result, and it prints the result. So by this way, I was able to successfully, earlier, another function didn't know what the value was. Now I was able to say, hey, main has a value called 5, and I want you to double it, send it back to me. So I was using another function to be able to do that job by passing it inside the parentheses. And so that's what the parentheses and functions are for. So can I send more than one value? Sure. Why can't we do another function called show product and say, hey, I can accept 2 numbers and I will return, or I will print the product of those 2 numbers. And I don't know what those 2 numbers are. And main can say, okay, I have number 1 is equal to, let's just say, we'll ask the user here. And because it's going to be a number and we're trying to perform multiplication, we're going to say, we're going to convert it to an integer. So I'm going to do the same thing, and I'm going to say, user, you give me 2 numbers, and I will store them in these variables. And instead of me doing the computation, I'm going to call another function called product, and to that product, I'm going to pass these 2 variables. So in this case, number 1 and number 2 spelled out are called. So this is the function call with 2 arguments. So we are sending these 2 as arguments. And in this function definition, this is a function definition with 2 parameters. So when we're passing it in a function call, these are called arguments. When we're receiving it in a function definition, these are called parameters. So again, let's follow the execution. I'm just going to delete these just to make sure there's no confusion. Okay, I'm going to also delete that for now. And so I just only have one function. So let's let's follow the execution. First thing is the main function call, and then there's an assignment here. through an input statement. So we're getting the number from user and we're converting it into int and storing in a variable called number1. Second statement does the same thing, but it stores in another variable called number2. Now we're passing number1 and number2 to a function called product using the function call. So now num1 is an alias of number1. So now, according to this product, like I said, remember when Tom Cruise is acting in Mission Impossible, his name is not Tom Cruise anymore. It's Ethan Hunt, but it's the same person or the same value. So here it's the same thing. Number1 is now passed to num1, and number2 is now stored in num2, and the product is going to be whatever the product of num1 and num2. So enter num1, I'm going to say 25, and number2 is 2, so it's going to be 50. So we have successfully passed these two local variables from main, and main let this function have access to its variables through a function call. So how many arguments can you have? As many as you want. So you can pass. Here I'm only showing you two arguments and they're comma separated. That's the only rule, that they have to be comma separated, and you can send as many as you want, provided that you define your function also with the same number of parameters. So you cannot have a mismatch there. So that is how we pass arguments to functions. All right, so making changes to parameters. So for example, for whatever reason, yes, the user gave me, here in this case, it's 25 and 2. What if I decide, hey, my function wants to change it to something else, and so if my function decides to change it to something else, will main reflect that? So that's kind of what we're going to learn here. So we have seen that when an argument is passed to a function, this function's parameter variable will reference the argument's value. But any changes that are made to the parameter variable inside the function will not affect the argument. So if I say num1, I'm going to assign my own value. I don't want your 25 or whatever the user is going to enter. I'm going to override it and I'm going to make 45. And then when I come back and after the function call, if I try to print number 1, okay, so will number 1 now be 45 or whatever the user gives me? So let's take a look at that. I don't know why my code is getting collapsed here. Okay, so like we did earlier, let's say the number entered by user is 25 and the second number is 3. Of course, the product is correct, which is 25 times 3, but when I tried to print number 1, it did not take into account that that variable was modified to 45 by that function, because the scope of num1 is only inside this product. Outside this, any changes that you make to this parameter, even though it's being passed to it by main, has no effect on what this number is. So this number 1 will always, unless main changes that number 1 to something else, number 1 will always be the same value. So that is kind of the example. Let's see what I had for you earlier. So let's see. Follow the execution. So we're going to jump to main. So that's the very first statement, value is equal to 9. So there's a value, there's a variable called value, and its value is 99. So before change me call, so I'm going to print value first, and then I'm calling another function called change me. I'm passing this 99 to that function, and change me is accepting that inside a parameter named arg. So arg is the new name, and voila, I changed arg to 0. So arg is not 99 anymore. I change it to 0, and when I print it, it's going to print 0 definitely. And then after this executes, when I call back, when I execute the next print statement, and after the change me call, and I try to print the value you would think would be 0, but inside the function, yes, it made successfully changed arg to 0 and it printed that 0. But once it exited that function and came back to main and you're trying to print value, this change did not happen in main, so main retains the value of 99. So, and that's why it's printing 99. So you can take a closer look if you don't understand. So this form of argument passing, when a function cannot change the value of an argument that was passed to it is called pass by value. So remember that. So we are when a function call in this is called a function call, and call by value. This is another way of calling. A function call can be called by reference, where we're not going to give the value 99, we're going to give the address of where value is located in the memory, and that's called call by reference. For the scope of this class, I don't think we're going to be doing any call by references, so just let's stick to call by value. And anyway, so far we've seen that a calling function can communicate with the called function. So the calling function in this case happens to be main. Main was successfully able to send its value to another function. But this function, what if this function makes this change and it wants to say, hey main, I wanted to let you know that I've changed to 0, and now from now on its value needs to be 0. So that communication is what's missing, and that's why there's a discrepancy here. And how can we do that where a function can make whatever changes it wants to make to a variable and then be able to send it back to main? So that is called returning a value, and we will see how to do that very briefly. So that is pretty much all I wanted to share in this lecture, and I will see you in the next lecture with more arguments and how to do keyword arguments and stuff like that. Hello. So this is lecture number 4, chapter 5, functions, and today we're going to see keyword arguments and positional arguments and one other thing. So let me go ahead and share my screen. So all right, so we have seen earlier how to pass arguments to a function call. So when you're calling a function, you can pass something to the function and that function can manipulate those values. And we've understood that you can pass as many arguments as you want, provided you declare when you define your function header, you accept that many number of parameters. So that was just one of the ground rules. So we can also, let me go ahead and take all of this out and let's see. So without all this, I'm going to take that all out and I'm going to just simply print number, and then I'm going to print multiple, just to see how the order is. So in main, I have a variable called n, and then I have another variable called m. Both are being provided by the user. And to make sure the names match here. Okay, so I have two variables, and I'm passing those two as arguments, passing n and m as arguments. So when this function call is made, n is this value, and it is going to be stored in the variable name number, and m is going to be stored in the variable name multiple. So however number of arguments you're going to be storing, those will be stored in the appropriate references or parameters here. So n is the first one, so it's going to be in the first one. M is going to be the second parameter, so that value be in the second, so on and so forth. So you have to pass it in the exact order as you want, as it's been defined here. So what if, okay, so let's just say and see just to make sure. So the first number is 10, so n is going to be 10, and then next number, enter the multiple. So the multiple is going to be, I'm going to say, okay, 3. So m is going to be 3. So when I pass this and I try to print number, is going to print 10 and 3. So there you go, in that order. So basically, whatever order you specify here, these values. So if I try to pass m and n accidentally as a programmer, I could make that mistake. Now your entire programming logic is going to be messed up, because even though I'm giving it 10 and 3, when it's getting passed, it got flipped. So whatever order you have defined, you have to pass it in the same order when you're calling the function. What if I don't want to do that? There's another way called keyword argument. So here I can say, instead of saying m, I can say multiple is equal to m, and number is equal to n. So I am telling this function call that, hey, whatever value that I'm giving to you, I want you to store it in this. And number, whatever I'm giving to you, store it in this. So when I try to do that, it doesn't matter that the order is flipped. I am specifically instructing Python to store it in this and this. So when I do that, now it's going to be 10 and 3 again if those are the numbers that I enter. So now my order is restored. So this is called keyword argument. So earlier, the way we passed was positional, passing by position in that particular order. But here, it doesn't matter what order, what sequence you're going to pass it. If you can tell it whatever value, it needs to go in that specific. So the only way this code is going to break is if you choose a value here. So instead of multiple, if I say mul, then that's when the program is going to break, because according to Python, there's no parameter named as mul in the function definition. So you have to make sure when you're doing keyword arguments that you use the correct parameter names. So that is called keyword arguments. So in keyword arguments, position doesn't have any relevance. So can we do both keywords and positional arguments? Yes, we definitely can use a mix of those, provided we follow one rule. And that is, it is possible to mix positional arguments and keyword arguments in a function call, but the positional argument must come first, and then you can use as many keyword arguments in whichever order you want. So for example, let me grab this code snippet here, and I'll also erase the output here. So all right, so that's one example. I'm going to cut it out, and we'll see later. So I have 4 variables defined in main. So obviously this is not going to really do a whole lot because there's no function call for main. So remember, the execution call, the program execution will always start at main function call. So when the function call is encountered, then the program jumps to the main function body. So I see 4 variables being assigned to F, L, M, and E using input statements. And I am calling a function called displayStudent with F and L because I'm trying to pass the first name to first name here, last name to L. Now, originally, if we did what we did with positional, I would be passing M, which is the major, and E, because that's in that order. But because we have an ability to mix keyword arguments and positional, now I can say email can take E, major can take M. So right here, email is the last one when I'm defining the function, but now I'm calling it third. But this happened to be a keyword argument, so E's value will be stored in the email, even though email is the fourth one, because of the keyword arguments. So there's only one rule for this particular mixing is you have to use all your positional keyword or positional arguments first before you can start using any keyword arguments. So let's see what the other line of code was. So you can also do FL, and major is equal to M, email is equal to E is also going to yield the same result as this one, because the appropriate value is getting fed to the appropriate parameter. So you cannot do something like first name equal to F and then say L and major is equal to M, email is equal to, this is not going to work because you have used a keyword argument first and then you're trying to use a positional argument. So this will be correct only if you do last name equal to L. So basically use all keyword arguments or all positional arguments, or if you want to do a mix, make sure you use your positional arguments first, and then you are no longer allowed to use any more positional arguments after you use your very first keyword argument. So that's about the only rule here. All right, so let's talk about global variables. So we have talked about what a local variable is. A local variable is any variable that is assigned a value inside a function. So when I say inside a function, that means it's one indent over after the function header or inside somewhere inside the function body. And its scope is only visible for that function. But conversely, there's what's called global variables. Global variable is a variable that's created outside all the functions. So let me take this code snippet and global, the name gives it away that it is available to all the functions, not just to any particular function. It is available for everybody. So the way to create a global variable is just like you'd create any variable, but you do not create it inside any function, not even main and not even any function. So by rule of thumb, you are going to declare a global variable at indent 0 position. There will not be any leading spaces, and that Python will consider that as a global variable. So when I try to print var inside function 1 or function 2, and I call those two functions, of course, I don't have a main here, which I should technically have. So let's just do that first. And then I'm going to call main. So again, the execution starts at main. So the very first is the function call, which is printing there. The second function also is printing there. And each of these functions knows what var is, even though var is not assigned inside that function. So just for kicks and giggles, I want to show you. So what if I change var to 15? In the first function. Now the first function has changed the value of var, and as far as that function goes, that is the value of var for it. And when you go back to the second function, the global variable still retains its original value. So the way to change um, the global variable's value to 15 and make it reflect everywhere, that would be that now the second function, so we've declared a global variable, but this function changed the global variable name by using the global keyword and say, hey, where is the global variable? And then I'm trying to change this value to 15. So when this function 2 happens, and then function 2 looks at trying to print var, it's not 10 anymore, it becomes 15. So that is a downside of using global variables, that any function anywhere can manipulate a global variable, and it's really hard to track for a programmer where the change is where it's coming from. Why do we use global variables? So for example, when say you have a car dealership and the commission rate for dealers is across the board, it's 10% for everybody, um, no exceptions. So let's say commission rate is equal to 0.1, and then that's what something you want to make default for all your dealers. So no matter which dealership or which person you're taking, that's the same value. That's when you use a global variable. Another good example is for all the students in ULM, their college is going to be ULM. It's a global value and you want to set it only one time. You don't want to set it every time at every screen. So those are the instances when we use global variables. But the downside is when other functions can easily manipulate a global variable and a programmer finds it really hard to track down where that change is coming from. So those are all the issues with global variable, and it makes a program very hard to understand. So how do we get around it? I do want a variable that I want to be able to use across the board, but I don't want any functions to be able to change that value. Well, instead of using all lowercase, we will just simply do all uppercase, and this tells Python, or a rule of thumb for a Python programmer, that college is not supposed to be manipulated anywhere else. So if I try to manipulate global college and I say college is equal to, say, LA Tech, and then if I try to print college here and here, let's see what happens. See, Python will let you do it no matter what. So it doesn't care. But as a programmer, when you look at uppercase and you look at the fact that you've created a global constant, so this is more like a friendly agreement between programmers that, hey, Python is a very friendly language. It will let you do whatever you want to do. But can we as programmers come to an agreement that when you see a global constant, you don't do stuff like this? You do not try to go ahead and change the value. That's a no-go area. So that's kind of why we use global constants. And the rule of thumb is that global variables and global constants are created at zero indent position. So if you see these have no indent, so that is the way you can create a global variable or a global constant. So that's pretty much all I wanted to cover in this lecture today. So hello. So this is lecture 5 of chapter 5 functions. And let me share my screen and get started. So we started, I think we stopped off at global constants and global variables. So now, so far, all the functions that we have seen were void functions. Void functions were the function wasn't returning anything to the calling function. We have seen how the calling function can send something to the called function, but now we're going to see how the called function also can send something back to the calling function. So any function that is returning something to a calling function is called a value returning function. So the value returning functions will always have a return statement with a space, and it's going to try to return something. That's the cue. So if you do see a return statement like this with something else passed, that's a value returning function. There are two types of value returning functions in Python. Number one is a standard library function, which means whenever you install Python on your computer, or in this case, we're using REPL. So whenever you create your own Python REPL, Python gets installed on this particular container, and it comes with a standard pre-packaged library functions that a user can take advantage of. And we have been able to take advantage of some of those value returning functions or standard library functions, and we will see that in just a second. But let me just go ahead and see this snippet of code and see how that works, okay? So let's get started. And again, I may have forgotten to write the main function. So anytime we are using function, it's a good rule of thumb to have our main function written down. So all of this is main function body. So this is not going to do anything until I call the main. So anyway, the execution starts at the main function call and main gets called. And the very first thing is a function call. But up until now, we did not have anything leading the function call. That was because the function was not returning anything. So let me jump to the function and look at the function body. So the function body is asking the user to input a number. It's storing it in a variable called number. And the return statement is converting that number to an integer, and it's sending back. So whenever the return with this something next to return is encountered, this number is sent back to main. But then main has to collect it in something. So that's where this comes from. So the A equal to, meaning this value, the integral value of the number entered by the user, is now stored in a variable called A. Does it have to be A? Can it not be number? Of course, it can be anything you want it to be, but just to show that it's possible that you can collect in whatever variable. And for the scope of main, A now becomes whatever is the value of the number. So let's get started. So we're printing A, and then we're printing B times A times A. So we're squaring A, and then we're printing the square. And that's pretty much very simply the logic of this code. So it's taking 1 second. Let me just get, okay. So enter a number. So if I enter 10, it should display 10 and the square of 10, which is 100. So basically what we have established is there's a handshake because this number is entered by the user in the scope of this function named function. But when it is being printed, it's being printed in main. So how does main know it? Because of this return statement. So if I use control slash and I comment at that part, now if I try to run the code, and I hit 10. Now main doesn't know what A is. That's because the function wasn't returning anything, or in other words, the function was returning none. And that's what you see here, none type. So if you try to multiply a none type times none type, it's not a valid value. So that's the basic crux of how value returning functions work. So let's go back to the next part, or the first part of value returning functions, which is standard library functions that come prepackaged with Python when you install Python. Of course, I am not going to be able to teach all the standard library functions that come with Python in this class, but you're welcome to give it a shot. Go Google and look for all of that and whatever. But I will be teaching two specific modules because that's what is covered in your textbook. That doesn't mean those are the only modules available in Python. So the first one is math module. Second one is random module. So how to take advantage of those modules that come prepackaged for our programming. But before that, I want to tell you that we have already seen at least 3 standard library functions that came with Python. Number one, it's the print statement or print function. So anytime you see a statement with open close parentheses, up until we get to chapter 10, think of that as a function. It is a function that takes an argument. So we've seen print statement. If you do simply print, Python will not have a problem. But if you do give it something, say 4, which is an integer, so remember our data types. So if I also say true, so this is now accepting print, is accepting this as an argument. So I can conversely also do this. So I can say var equal to true. Now I've created a variable and print is accepting that as an argument. Can print accept more than one argument? Yes, we have seen that too. 4. Let me just go create all the different types of variables we have of data types. And the var 4 would be a string, and that could be hello. So this is a Boolean, integer, float, and a string. And those are the primitive data types or the basic data types in Python. And can we print all of them in one print statement? We were able to do that. And these are 4 arguments that we're passing to the print function. So it was able to print all of them. So that was one that we saw, that it is accepting arguments 0 through any number that you want to send. So it's optional how many you want to send. And it's not returning anything, it's just simply printing those values. So print is a classic example of a void function. How about input? So input, I can simply do that. And right now, nothing is happening. So I don't know what's going on. I can enter 4 and hit enter, and the program execution stopped because number one, we did not tell the user what to do. Okay, so while it's not a crime, it's not a problem, the program is just showing a blank white screen and it's expecting the user to do something, except the user doesn't know what to do. So now if I run this program, it's going to say, hey, enter a number, and I can enter, say, 5. It's not doing anything with that 5 because we are not collecting that in a variable and storing that in a value and say, okay, now I say print user choice is, and then I'm going to print choice. Now there we go. If I run it now and I enter, say, 12, the user choice is 12. So it's printing. So what is input at this point? You can, if I have to break it down, input is a value returning function because we were able to collect that value inside a variable. So very similar to what we have seen earlier. Here we had a equal to a function call. So here a variable equal to a function call, only this function is taking one argument. Can it take more than one? Let's try it and give it a shot. See what that does. So basically input is not expecting another argument, and it's also saying input expected at the most one argument. So can we simply say that input is a value returning function that takes one and only one argument, right? So that's what input is. And print was a void function that takes 0 through infinite arguments. I don't know. I'm not comfortable to say infinite arguments. I have never tested the threshold of a print statement of how many arguments it can take, but hypothetically it can take as many as you give it. So this is a void function. This is a value returning function. So we are going to see some more value returning functions other than the input statement. And the last but not the least is the range function. So let's go back. We've already seen range. So remember how range operated. Range returned a sequence. Of course, we cannot just simply print a sequence. We have to use a for loop to print a sequence. So range accepted, say 2. So if you gave it 2, range was perfectly okay. So it needed at least one argument, or you can optionally give one more, or you can give another. Of course, that's not going to work. So a start, stop, and a step was what, but you absolutely, these two were not mandatory. You can go with just one or two. So can I say range is also a value returning function that takes at least one and at most 3 arguments. So we need to understand this the technical definition of whatever we're saying here. So just because we said print, we need to understand that we're calling a function called print with this many arguments, and we're calling a function called input with a string, and it's returning another string, because remember, input always returns a string even though you enter a numeric value. So value returning function that takes and returns one string, one and only one string. Okay, so we have seen some. Let's see some more, but these that we're about to see will actually require us to import modules. So as you can remember, we have written our previous code in different files. For batter, we wrote it in batter.py, flavor.py, icing.py, and so on and so forth. And remember when I said, even though they look like files, we call them modules, and we used an import statement to be able to use them in our code. So very similarly, the standard library functions are also stored in Python files that are called modules. And to be able to use any function in that module, we should first import it. So if I want to use the math module, the very first statement I would be writing is import math. As simple as that, nothing else. The only downside is we really cannot see the contents of math. Here, you're able to see the contents of my file. You can see what are the functions defined. There's at least one function here. And you're able to see that, hey, even though it has a return statement, there's nothing trailing the return statement. So basically, it's not returning anything. It's a void function. So you can see the contents. But the problem with these standard library functions are you are going in blind. And that's one of the reasons the standard library functions are also called black boxes. So you don't get to see the code inside them. But thankfully for us, we have Replit, and it can tell you, hopefully, any of the functions. If you type the math module name and put a dot, it's going to tell you every single function that's available in that module. And not only that, it will give you some information on what are the arguments. So here it is accepting one argument, and the arrow and float is telling you that it's returning a float. So you're supposed to give it some value, which is actually an optional value. So let's pick something that will make more sense and say log. Hey, logarithm. We all know what a log is. So these are all the math functions in SQRT. I'm going to use the SQRT function, which is going to provide the square root. So what it is asking from us here is it supports float or index. So if we give it a float value, it is going to return us a float value. So I am going to give say number equal to, for now, I'm just going to say 25. And I'm going to say, hey, can you give me the square root of number? Because There's no other way, no other mathematical operator in Python at this point is going to give us the square root of a number, unless maybe if you do star star 0.5, maybe that'll work. But square root is a very, very simplest form of a library function that I'm using. So if I do this, and if I run it, is it going to display anything? Well, let's go ahead and do that. I want to repeat myself so you'll remember it for future. So I'm running it, but nothing is happening. Why? Why? Because we're seeing that this is a value returning function. How do we know that? That just by clicking on it and hovering it, that arrow and float is telling me that it's returning a float value. So whenever a function is returning something, we have to collect it in a variable. So I'm going to say square root value is equal to, now this is my variable that I'm collecting the value in, and I can print that. Oh, sqrt, and I'm going to say value. So I'm storing this inside a variable, and now I'm printing that variable. Now it should print 5.0. Why is it printing 5.0 and not 5? Because remember, it returns a float, and float will always have a 0.0 even if it's an integral value. So can I combine both of these in one step? Because square root val is nothing but math square root number. So can I just simply consolidate both of these in one step? Yes, I can do that. So if you are doing a value, if you're calling a value returning function, you have to either store it in a variable or you have to print it. Those are the only two routes you can go about. So, all right. So what else can I do with math? What other math fun can I have? So when I do math dot, factorial, floor, seal. Yeah, there's a floor. So as you can see, I'm not going to go over everything. So even in my example, I just mentioned square root, but you are welcome to try every possible, anything that strikes your fancy. Go for it and give it a shot and see how that works. Replit helps you a lot trying to understand what that function accepts as far as arguments goes and what it returns as far as the data type goes. So, all right, the next one we're going to see is the random module. So the random module, you can import it by using the random module name. And then if you try to use the random as a prefix and put a dot, immediately Replit populates all the possible functions available for us to use. So we're not going to check out every single thing today. So first, what is random? Before we go any further, what is random? Sometimes we need to generate random numbers for various applications. Say for you're writing a program to generate a lottery number and you're trying to simulate a lottery picking. So you have to pick a number between 1 and 100 and say, okay, that's your lottery number. Or you're playing bingo, or an application is doing bingo. So it has to randomly pick a number out of a given preset of numbers. That's when we use random. So random numbers are useful for a lot of different programming tasks. And yeah, computer games use the dice rolling, any computer game, that video game that involves dice rolling, or even a card game. Each card can be represented 1 to 13, and then when you shuffle the deck or when you randomly distribute cards to a player in your game, what you're actually doing is you're picking 13 numbers randomly and assigning it to each player. So that's pretty much the applications of random number. So there are three functions that I'm going to talk today is how to generate a random integer between 1 and 100 and what is the function that will help you do it. So I've already imported the random module. So now I put dot, and the function that let me do is called randint. Randint, explanatory random integer. And then as you can look in the sidebar in the gray, it says a int, b int, and then the comma and int. So what it tells me is it accepts two integer values and it returns one integer. So based on that, I can pass it two integer values and it's also returning one integer. So you have to store it in a variable. So right now I'm just going to say num and I'm going to print num. right? So what I'm trying to tell Python is, hey, go look up the random module and find the function called randint, and what it's going to do is it's going to generate a random number between 4 and 67, and then we're going to store it in a variable and we're going to print the number. So when I do that, so I'm going to erase the previous output. It gave me 32. Okay, delete it again and let's run it again. This time it gave me 5. So the more number of times I'm going to run it, so for kicks and giggles, for I in range 45. So if I know how to do it one time, I definitely know how to do it 45 times. That is simply by putting the code inside a for loop. And if I run it, it's going to generate me 45 random numbers between 4 and 67. And of course, some will be repeated sometimes, but that's how it goes. So this is if I want a random integer number. What if I wanted a random float number? So how would I do that? So I have given a couple of try this for you, and I've also given the answer. Um, so there's another called rand range. I'm giving you rand range because we've already seen range. So based on that, rand range works. And what does it do? It takes the same arguments as the range function. So whatever you would provide to a range function, you can provide it to rand range, and it will generate that number from that sequence. So let's see how that works. So before I do that, I'm going to do rand range and open parentheses and okay, do that. There you go. So if I hover on it, rand range takes start an integer, stop an integer, or none. That means it's optional. The second one is optional. The third one, if you don't provide anything, it's simply assuming that it's step one. That means every consecutive number. And what is it returning? Look after the arrow. It's going to be an integer. So rand range accepts 1, 2, or 3, just like range, and it's going to return from that sequence, it is going to return the integer. So for example, I want something between 3 and 100 every 4. So the sequence, let's do 3 and 20. So what would be the sequence here? The sequence it would start at 3. The next is, so we have to step by 4. So that is 7, 3, 7, 11, 15, 19. That's it. 20 is not included, so 19. So out of these 5 numbers, random is going to pick one of them. So that's pretty much what happens here. So I'm going to store it in a variable, and I'm simply going to print it, or I like to actually do it all in one because it's a value returning function that's only returning one value. I can simply put it in a print statement. There you go. So out of the 3, 5, 7, I'm going to delete that. Now it printed 15, 7, 11, 19, 7, 3. That's it. That's all the possible numbers it can do is 3, 7, 11, 15, 19. And then it'll just keep repeating the more number of times you enter. So that's pretty much how rand range works. The last thing is how to create a floating point. So all of these are integers. As you can see, all of these are integer numbers. So how about I create a random number, but it's a floating point number. That is when I would use what's called a uniform. So I'm not going to type anything. So I'm using a function called uniform, and I'm telling it, hey, between 1 and 10. And why am I giving, I don't have to I can simply give integer values, but it is still going to return me a floating point. So let's go ahead and see that. So between 1 and 10, it found a floating point for me. The more I execute, it's going to keep giving me random floating points. So I think I have a try this for you. Take a look and see. So if you hover on uniform, it will tell you it's accepting 2 floating points, A and B, and it's returning 1 floating point number. So Replit is very friendly this way. It's not a black box no more if you're using Replit. Anyway, so these are all the standard library functions, and we will figure out a way how to use them in our computations, in our programming somewhere. Um, let's go on to the last section of this chapter, which is user-defined functions. So what if I don't have an application for standard functions? I want to create my own functions. So that is when, and we've seen that example earlier, how to create a value returning function. So let's see some more. So I have a main function, and the main is called, and the very first thing that we see is a call to a value returning function call, and it doesn't accept no arguments. How do I say it accepts no arguments? Because the parentheses are empty. That means it's not taking any arguments. But how do I know it's a value returning function? Because there's a variable leading in front of it. So that means it is returning something, and we are collecting that in a variable called correct GPA. So what is the function body all about? The very first statement in the function body is it is collecting the GPA from a user, okay? And then it's trying to convert the GPA to floating point. And using an if statement, we're checking if that GPA is between 0 and 4 by using relational and logical operators. So if it is greater than 0 and at the same time less than 4, that it is a valid GPA. So when that happens, and only when that happens, we are returning the GPA, which it's going to be correct. Else, we're going to print invalid GPA entered. That's pretty much it. Earlier, when we saw the example, the return was not inside an if block, but here there's only one scenario in which this function will ever be exited out. That was only if you provide the correct GPA. So, and then the correct GPA is being printed. So let's just go ahead and run this program. And also, here's a disclaimer. We are converting this to a floating point, assuming the user is going to give us good values. He's going to give a numeric value. So I can't get my cursor to click on it. There you go. Got it back. Stop it. Run it. And then this time I'm going to enter 2. Is that a valid GPA? Yes, it converted that, and main was able to successfully get it from the validate GPA function and be able to print it, because as far as GPA values go, only the validate GPA is the one that's collecting those values. How was main able to print it? Because it was able to return it and we were able to collect it. So what happens if I enter 5? It's going to say invalid GPA entered, and we are getting none, because whether or not a return statement is there, as far as visibly as we can see, we can always assume there is a return at the very end. The very last statement in any function is going to be a return, which means we are returning a none type. So if you're not returning anything and just a simple return statement, then that means we are returning a none, and that's how Python knows that data type as, and that's what it's printing. So when we're trying to print correct GPA, because it never encountered this return GPA ever, it simply jumped to the else block and it printed this statement, and the next statement was really nothing, and the last statement would be like a return none. So that none got collected in correct GPA, and we were able to print the none here. So that's what I want you to understand, that anytime you see this none in your print statement, that means a return is missing. You're forgetting to return a value. You simply have a return, or it's not a value returning function at all. So that's pretty much all in this function. Let's see what else we have. So there's another scenario. So in this case, we're only returning one value. But before I go there, what did I mean when I say the user only gives us good value? So what if the user, when I say enter GPA, normally you would think, okay, GPA, it's a numeric value. I'm supposed to give a number. But what if the user is quirky and he says apple? Ooh, there you go. It broke my code, because when you try to convert apple, which is a string data type, to a floating point, it's not going to work. So that's why our code broke. And how to prevent that from happening, we'll see that in the next chapter using exceptions. So anyway, the second scenario I am going to say is, let's say, get values function. We're calling a get values function, and we're collecting the values in 2 variables called student name and student major. That is because this function is returning not one, but two values. So can you return more than one value to a calling function? Yes, you can. And there's no limit on how many you can send. I have never tested what that limit is, but I can tell you, you can send a lot of return values there. So the only caveat is as many you are returning, you are supposed to collect them in that many number of comma separated variable names and then an equal to and the function call. So if I want to define, if I want to put a comment, a line comment on what is this line actually doing, it is calling a value returning function that returns two values and accepts no arguments. Again, how do I know that it's accepting no arguments? Because the parentheses are empty and it's calling a value returning function that returns two values because I see two variable names here. That's pretty much all there to it. So when the function call happens, the execution jumps here and the user is asked to provide a name and a major, and those values are returned to main, and then the execution jumps back here and those are stored here in these two variables, and we were able to print those too. So for kicks and giggles, I'm going to go ahead and call them the same name as the return values just to show you that you don't have to use a separate variable name. You can use the same variable name. So just as long as they're the same, I guess, and spelled. Even if they're not spelled correctly, just make sure they match. And when you run it, so the user is going to be asked for a student name, and I'm going to say John, and the student major is accounting. And there you go, it printed those two. So a handshake happened between main and get values, and main was able to. So can I send something? What if I wanted to send something to the calling function? So I can also do that by doing, say, I want to say, hello user, and I'm passing a string, or I can simply save this in a string. Okay, and then I'll pass this to the user. The only change I have to make is I have to make sure my definition reflects the same. So my definition, I'm accepting it in a parameter called str. That's it. So basically now this changes and accepts one string as argument. I've completely changed the definition. So the function call has changed. You have to also change the definition as necessary. Now it's printing hello user, and now I print enter the student name is Jenny, and accounting is department is finance, and it's printing Jenny in finance. So basically I'm able to pass something from main to the function, which is nothing but the hello user string, and I'm able to get back two values from the called function back to the calling function, and I was able to print them. So a two-way communication has been established. Regardless, this is still a value returning function. There's only one scenario that we will be discussing later on is there is a provision where you can collect all the values in one variable and you can call it student. Okay, so it is possible. You can return any number, say 5, true, CWID, oh, sorry, TRUE, which is a Boolean, and I will return a floating point, and I will return another string and say student. Okay, I can send like 1, 2, 3, 4, 5, 6 return values, but I can collect all of them in one variable. That is a possibility. But now this is not it's a value returning function that it doesn't return two values, it returns one tuple. Okay, and what is a tuple? We'll see that in the next in lecture, not lecture, chapter number 7. We will get to see what a tuple is. But I can collect everything in one variable, and when I print it, it'll actually print me a tuple, John and history, and there you go. So this parentheses that we see signifies that that's a tuple, and this tuple has 6 values. So all of these values are successfully stored in this tuple. So we will see what that is. But until we get to lecture 7, we will have to make do with individual variables for as many returned values as are being provided. So that's about the scope of this lecture that I wanted to share with you all. So this is the end of chapter 5 functions.